Hello gentlemen, welcome back. Hopefully you guys are finding some success solving these trig equations. The next set of videos is going to look at some different formulas that we can use, sort of identity type formulas that we can use in solving equations. There's quite a few of them, so I'm going to make a bunch of shorter videos to show you how they work. You don't need to memorize every one of these formulas. What you do need to do is be aware that they exist, and then you'll be able to look them up and use them in the problem solving process. So let's get started. The first one we're going to look at is the sum difference formulas. Okay, and there's a sum difference formula for each. We're going to look at sine, cosine, and tangent. Okay, and so what I want you guys to do is be aware that these exist. Okay, and so if I get something with a sine u plus v, I know I can replace that with sine of u, cosine of v, plus cosine of u, sine of v. Okay, I'm not going to read through every single one of these formulas, but just make sure that you're aware that they exist. And let's do a couple examples on how to use them. Okay, so let's get started. So if I have something like this, cosine of pi over 4 plus pi over 3, if I combine those two together, let's just do that and see why I'm writing it out like this. If I have pi over 4, let's get my pen here. If we have pi over 4 plus pi over 3, if we think about a common denominator, common denominator would be 12, so I would get 3 pi over 12 plus 4 pi over 4 pi over 12 gives me 7 pi over 12. Now, I don't know from my unit circle what 7 pi over 12 is. Okay, so if I break that up into this stage like this, I can use one of my sum or difference formulas. Okay, and the sum of difference formula here for cosine, this is a sum one, is cosine of the first plus times cosine of the second minus sine of the first, sine of the second. Okay, and I know what cosine pi over 4 is. I know what cosine pi over 3 and sine pi over 4 and sine pi over 3 are. So that's why this is a useful formula for us. If I plug in, I note that cosine pi over 4 is root 2 over 2. Cosine of pi over 3 is a half. Sine pi over 4 is root 2 over 2. And sine pi over 3 is root 3 over 2. Okay, if we go through and we do that, you'll see that we get root 2 minus root 6 over 4. Okay? Let's do another one. Here's sine 5 pi over 12, and we want to do something similar that we did right up here. We want to break 5 pi over 12 into a sum of two that we already know. And if I do that, we'll see that pi over 6 plus pi over 4 is equal to 5 pi over 12. Let's take a quick look at that. So if I have pi over 6 plus pi over 4, again, my common denominator is 12. So I get 2 pi over 6 plus 3 pi, over 12. And that's going to give me 5 pi over 12. Okay, so I'm able to rewrite this in terms of these two angles. I know my sine and cosine of pi over 6. I know my sine and cosine of pi over 4. So that's going to allow me to write it out like this. Okay, sine of pi over 6 is a half. This is root 2. This one right here is root 2 over 2. Right there is root 3 over 2. Similar to the last one, except now we're going to get a plus sign instead of a minus. Okay, let's use this to solve an equation on the interval 0 to 2 pi. So if cosine x plus pi over 4 minus cosine x minus pi over 4, let's use our sum difference formulas here. The first part here, this part right here, that goes right there. And this part is going with that one right there. Okay? So again, I know cosine pi over 4, I know sine pi over 4, so I can simplify this down. This is going to give me root 2 over 2x, cosine x, minus root 2 over 2 sine x. Over here I'm going to get minus root 2 over 2 cosine x minus root 2 over 2 sine x. What you're going to see is the cosine terms are going to cancel out, and I'm going to be left with just negative root 2 sine x is equal to 1. Okay, so after plugging all that in, that's what I'm left with. I'll divide by negative root 2, which I then, remember, I have to rationalize. So when I did this step here, I got 1 over negative root 2, and so I multiply top and bottom by negative root 2, and I got root 2 over 2. Okay, multiply top and bottom by root 2. I rationalize. Now I'm looking on 0 to 2 pi. When is this going to be true? So I'm thinking I'm going to be in quadrants 3 and 4, and so I'm going to be equal to 5 pi over 4 and 7 pi over 4. Okay? There are a couple examples on using the sum difference formulas. I want you to read this section 5.4. Here's some good examples for you to do. Here's some practice problems. But again, basically we looked at the sum difference formulas for sine, cosine. There's also one for tangent. You'll get some practice using all of those in these problems here. Again, remember, you don't have to memorize them, but you do need to know that they exist and that how to utilize them in the problem solving process. Okay? Have a good day, fellas, and if you have any questions, let me know.